just come get help. So those of you at the standing desk that are at awkward angles right now, cough, cough, Colin and Max, you need to be turned this way, checking homework with us, so I should see you turning back and forth. Or turn your desks. They're like that for Math 7, so if you need to turn it right now, turn it. You know those desks can move. Look at that. Maddie. Because it's not nice, right? Where these numbers get less nice. So F on 114. Now, there's actually a couple different ways that you could write this answer. So that's not the only way that you might have that answer written. But the whole point here is to simplify, right? And with fractions, part of our simplification is to reduce. So if I have 9 over 15, what's a common factor 9 and 15 can both reduce by? 3. So the first thing we're going to do is reduce both of these by 3, making this 3 over 5. Then we look at simplifying the variables by saying, okay, a to the 4th over, okay, there's no a's. So we're going to keep a to the 4th either in the numerator, or you could have put it off to the side here, but it's probably easier for us right now to keep a to the 4th on top. And then b to the 2nd divided by b to the 1st, just b. So 3 a to the 4th b over 5 is one way you could have this answer written, or 3/5 a to the 4th times b is also another way that we could have that written.
I need help on, like, for the,
Oh, Lily, thanks for raising your hand.
I think I might have made a mistake somewhere at
111?
Yeah.
Howie and Steve.
I arranged it as a bonus fraction.
So what are we trying to do to the recipe? If the recipe we have makes 48 cookies, but I only want to make 16, and I have no need for 32 extra cookies, no. I have a wedding in a month, not my own, but I am the best man in a wedding in a month, and I cannot eat 32 cookies right now. 30. I shouldn't eat 3 cookies right now, let's be honest.
why?
So, if I'm trying to go from 48 cookies to 16, I'm really scaling by a third, right? Like a third, right? So we can either divide by 3 or multiply by 1/3. So my advice, because I like multiplication better than division, and they're pretty much the same thing, is multiply by a third. But multiply what? Well, the butter, right? Since that's what they're asking us about. What's better than a mixed number? Impropers. Impropers are better or butter than a mixed number. So if I need 1 3/4, what I really need, if I make this butter as an improper, 7/4, then times a third. And yeah, you could use decimals, but I like fractions better than decimals. You all know my opinions about that by now. Multiplying fractions straight through the numerator, straight through the denominator. And yeah, this is when cooking's annoying, right? This would be like half a cup and then a tiny bit more. But butter actually comes marked out. If you've ever looked at a stick of butter, it comes like marked out where you can cut it exactly. So like, even if it says like half a pad or half a what, like there are markings on the stick of butters. It's like a number line, quite legitimately. If you look at a stick of butter, it's like a number line.
Mr. Hudson,
Hey, thanks for raising your hand, Jake.
I made mine so much more complicated.
You always can make it more complicated. Our goal here is to make it less complicated.
And then also, how I can make a triangle on C.
Which C?
9, 10. 9 on 10.
Wait, what is your question again?
Wait, I just need help on C.
So we are trying to find the length of the line segment. And what's funny about you saying you need help on C, I think C is one of the easier ones here. Easier, I said
I know, but
That's saying I'm dumb.
So if
You're saying I'm
if, no, I think you're going to have one of those moments where you're like, oh, I way overthought that. X of 3, y of 2. X of 3, y of negative 3. I'm going to make a real quick. So x of 3, y of 2. X of 3, y of negative 3. I don't even have to make a triangle here, which I think is what's messing you up. So what is the length between them? That's countable. We don't have to calculate that. That's it. I don't want to use the E word, but yeah, you got to that answer pretty quickly. It is 5. Yeah. Now, in A and B, they aren't in a straight line, and we have to then form a right triangle. So let me give an example like that, one of the tougher ones. So 2, 3, right here. Negative 1, positive 2. So since this line is diagonal, we cannot just count diagonals. So we got to set up a triangle and do the Pythagorean Theorem. Right? So set up a triangle. This leg is 3, this leg is 1, and then we solve.
1 plus 9 is 10.
Yeah, because 1 squared is 1, 3 squared is 9. So then square root of 10.
We can say radical 10.
Sure. You can say your answer is radical 10. You can leave it in the radical form and be a surfer bro.
Radical blue.
Hang 10, radical man.
Or you could also use like the about equals.
Yeah, we could approximate. Yeah, the squiggly equals, as I like to say. Other questions? Because I do finally know how to teach you that patio problem that I had made up, which is ironic. That I couldn't remember the problem that I had made up. It just felt sad yesterday. Wait, Max? Absolutely. Probably Diane. More friends. Hey, Dr. Ross. Doing well. This is the Math 8 class. You guys want to say hi, Dr. Ross? So what's weird is they're not normally in rows like this, so they're going to be like probably super well behaved today. Normally we're in groups, but we're just checking homework super fast. We got a couple things to do, and then I'll let Miss Hunter steal her people. So guys, honestly, I'm real excited to get to that patio problem. We can check this again later, and I'm going to be super honest with you. I'm not grading papers tonight. My game night group decided we're grilling dinner tonight, so I'm not worried about your 924 getting turned in tonight. You can turn it in tomorrow. I'm going to game night this week. So, what do you mean thanks? I'm giving you the freebie. Yeah, we're going to grill tonight and hang out with Gracie and Cam. They're kids. Yeah. Yeah, that's a great question. Thank you for bringing that up, because if you looked at this when you came in, you'll notice this changed, but like most of us wouldn't notice if we didn't look at it really carefully. So tonight, I shifted stuff. We're not playing Jenga tomorrow because we went slower this week than we thought. We'll play Jenga next week. Okay, so tomorrow is going to be 927. Tonight's homework is just 926. You already have it, right? It's the one with the patio problem that I goofed up. Sure. Yeah, because 2 days. Yeah. Well, yeah, the weekend doesn't count. Goes too fast. Can't count. All right, so. I mean, just get it done and turn it in tomorrow then? Then it's not due on Monday since it's already turned in. All right, so this patio problem that we talked about yesterday. We were starting to try to figure out how to draw it, but there's a really big issue as I start to try and draw it. So I know you're not sitting in your groups, but if you can try to find a way to chat with some people close to you for like a minute, what's the problem with the setup that I gave you here? And it's not just because 2 years ago I wasn't as good of a teacher as I am now, but like I did this on purpose. We're missing something here. So chat with your team for like a minute or two, probably like 75 seconds. What else do you need before you'd be able to solve this problem? And then we're actually going to do this on graph paper. So you can draw whatever you want on here, but we're going to do it on graph paper. You know what I do? Remember what Chelsea told me? Well, not us dogs. Did not remember that until Chelsea was like, I'm sure painters don't remember that. I was like, oh.
So you could do
So it just says what information would you need?
I feel like I'm genius now.
I will. All right, what are we missing? Hold on, don't just shout it out. Did I do the post-it yesterday? Okay, if I didn't, so I did it with Math 7, but some people started to argue that I shuffle before I get to the bottom of the deck. So, shuffle to prove I'm shuffling. Now, little post-it on the first card. I'm not shuffling again until we get back to Aiden's card. So, Aiden, what's the problem here? Yeah, we don't know anything except for what Chelsea wants, right? Chelsea wants the lights suspended, 3 on one side, 2 on the other. And the other thing is, this is hard to visualize, just me throwing information at you. So, all right, so this was Kira's patio. Our friend Kira, we helped with the demolition and the tear out of all the old stuff, and then she had a concrete patio put in. So this is what they call stamped concrete. And I hung a bunch of lights on her patio for her before she had like a little housewarming party. And of course, Chelsea, my wonderful wife, then says, hey, I want that too. And she wasn't just talking about lights. She meant the patio. So, a lot of work. And, my good friend Dave that Dr. Ross and I were just talking about, we used to landscape. We used to do this as a summer job. And when they found out that I knew how to math, they were like, oh, Micah, you're on patio crew. So I installed patios for a couple summers. Me and Dave did all this on our own. So where we're going to place the lights is using these metal poles. And we're going to put 3 on one side and 2 on the other side. See that path that heads towards our garage? So the poles over here are going to flank the path, right? 1 on each side. And yes, those are disc golf baskets, if you see in the background. Yes, I'm way too into disc golf. So what you need still is dimensions, though. The patio is 21 feet on the sides where we're going to put the lights and 30 feet long across the patio. Here's where I did goof up. It's 21 by 30, but we counted these boxes yesterday and talked about the fact that there were like 16, I think, boxes.
Yeah.
Are 16 and 21 going to get along nicely? Not really. Yeah, but we want to be accurate here. So we could just use graph paper. Here's a thought. 21 and 30 do share a common multiple. So if you want to use the paper I gave out, you may. If you want to draw it on your own graph paper, you are welcome to. But depending on how many boxes your graph paper has is going to depend on your scale. So take a moment, decide where you're going to draw it. I don't really want to force it to fit right here. And I just like graph paper. You guys know I'm crazy. So this is still 926 if you're looking for a header. Or you can just call it Chelsea's patio. Because really, let's be honest, it's hers. With an A. Chelseasea. Chelsea's patio. 21 by 30. So we got to draw it out first, either on the paper I gave you or on graph paper. I'm going to do graph paper and see if I have 30 boxes wide, but I doubt I do.
Wait, 21 by 30? You do on that.
Oh, if I use the whole paper, if you're using the 5-star graph paper on the big box side, you do have 30 wide if you use like the whole thing. You got to use like the whole thing. So if you don't want to scale it, yeah, or you could flip over to the small box side. But since I can fit it, I'm gonna fit it over here since I already started writing. Sorry, what was that, Lily? Sure. What trapdoor? I don't even know what trapdoor you're talking about, so point it out to everybody.
So the wire is 3 points, not 3 sections. What? The lights, they have
Yeah, so this is why we're going to have to draw it. I think I know what you're trying to say. So on the section with 3, if we try to make it match what the patio looks like, we go corner, middle, and corner. Right? So on the section with 3, we go corner, middle, and corner. So, well, the corners are easy to place, but the middle might be a tad bit tougher. So got a light here. Oh, you can't see what I'm doing. Got a light at the corner. I'm going to go left side, has my 3 connector points, because when I think about my patio from above, I don't know why, but so corner, corner. What would be the middle of 21? 10 and a half. And then if you want to label, this will be 10 and a half. But I wouldn't put too many labels yet. So on the right side, where we only have 2 connector points, if I only have 2 posts over here, I might need to zoom up. If I only have 2 posts over here, how many sections does that create? 3. So what's 21 divided by 3? 7. So each of these is going to have 7. So here's one side of the path, here's the other side of the path, and that is where our posts are going to go. So go ahead, grab that ruler that we should have since it was on the list of things to get out. Yeah. And this doesn't have to be perfect. Ha, yeah, unless we ask Chelsea, then she might say she wants it perfect. There are 3 posts on the left side and 2 posts that we're going to use on the right side. So the lights will look like this, zigzag pattern. Now, the other thing is we also have lights over here on the left side. Remember, you got to have the ambiance, we said. And we also have lights right above the path right here. Yeah, tell me about it. They're also the ones from Target that are not cheap. But they're nice. They're LEDs and they're plastic. So the first set of lights we got were glass. As soon as I threw a Frisbee for my dog and smashed one of the lights by accident, Chelsea was like, nope, we're getting plastic lights. She's smarter than me, that's obvious. So I think you might be able to tell already if our graph paper is scaled. These triangles are not identical to each other. Like a couple of them might be, but
It looks like McDonald's.
yeah, kind of, right? So with your team or whoever you want to get with, that is going to be one challenge that we're going to take on today. And then the second challenge, because then I'm probably just going to let you guys work for a while. Oh, we should also label this was 30 feet across in case we didn't, just to make sure that we got it. Now, there's no lights at the edge of the patio, but I'm just drawing that edge. And guys, this is, of course, a minimum amount, right? Because this is like an inequality we're solving. I might not be able to buy the exact length. So would I buy less or more? More. Because I would rather have left over than not enough. Trust me, when you realize you're one box short and you got to drive back to Target, it's a pain in the butt. Guess who's been there? In that situation of I'm one short, I got to go back to the hardware store or the Target or wherever. Brenda?
yes, I haven't driven there, but that's happened to me.
Good way to not self-incriminate there, Brenda. I was not the one driving the car, but I did get to Target. All right, so that's challenge 1. And then challenge 2, because I'm going to let you guys work, goes back to the flat family's house we talked about yesterday. So if... You don't like that house. Well, I don't know if that's good drainage.
I will go to
So-
buy the house.
So if your team decides we want to do challenge 2 first, that's up to you since we already kind of started this yesterday. What was this long dimension of the flat family house?
32, no, 60. 60. 60.
Wait for feet. 60 feet. Thank you for the label. What was the shorter dimension? 32. What do we know? I should probably take a hand for this. What do we know about the antenna post, Jake?
30.
Sorry, say again.
50 tall.
And what else? Because there's some other really important piece.
They're 5 feet below the top of the antenna.
So the antenna sticks up higher than the guy wires, right? So the guy wires are attached 5 feet below the top of the antenna, and we're going to assume that these are tight. So again, we're talking about a minimum. We'll buy more than what we actually calculate for, but this stuff's expensive. We don't want to buy too much extra. So those are your 2 challenges for today. Chelsea's patio and the flat family roof.
But what did you do after for the Chelsea's patio? One more.
Figure out how much total lighting I need to buy. There is lighting here. Here, I'll draw on it. Are you gonna let me?
So much. Don't you?
Everything is triangles, Jake. So there's lights here, 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 here. And yeah, if you want to start wondering how the path is actually like, wait, how do they all connect? Yeah, at one point I think I have like 2 strands of lights. I had to think this through really hard to figure out how to run the lights and like not double back on themselves. But that's all extra.
How
Frank.
did you do it? I want to know.
Almost. They're fairly straight.
Oh, thanks. I've been at this for a few years. I'm getting better. I can almost draw like a circular circle. Gus,
I know how to connect them without them overlapping.
you found the path in your head? Yeah, but then you gotta run an extension cord to that.
Yeah, it's bottom, like the right side is the bottom, down to the up,
Yeah. See, that's how it's.
I do a lot of these things.
There you go.
They're fun.
All right, you have the next 15 minutes to just solve those problems. I mean, you could just change the scale on the one side, but then in your brain, it's gonna be weird. There are trap doors on the patio. Be careful. It's very solid, but there are trap doors. This is just flat. It's just 2-dimensional.
I know, but like,
I don't know if we care about slope as much as we care about just being able to like draw a triangle, which I think you can figure that out. So if you'd like to steal your little group, that is totally fine at this point. Yep. Because I bet they could knock these problems out anyways. So we're probably going to wait to go over these till tomorrow, depending on how fast we go. But Aiden and Colin and Anna, if I could convince you guys to go with Mrs. Hunter again. Gotta wave to all your fans. Guys, I have 335 subscribers now. I went up.
You went up. You must have got one overnight because last night I looked and there was, I think.
You're keeping track of my YouTube?
Yes, I am. But honestly though, before I do my math homework, I will watch your lecture of the day or video of the day. That's what my parents called it. Like my dad is like, hey, did you listen to Micah's lecture yet? I was like, no, not yet.
For bad dad jokes.
It
You might want to take your stuff with you because you guys are probably going to be out there until after. I'm going to go remind Mrs. Goldring because it's been a long day. But yeah, it's fine. Hey, so if you guys end up late to language arts, it's fine. Okay, it's fine. No, I don't know. Brenda's right there. What?
Oh my god, yesterday I yelled so loud. At this point, you guys should
Yeah, we should probably just all the 3
Wait, where are you going?
I messed my grandpa 3 times. 3 times? 3. I think you said 2. This is the third one. Thank you. Yo, Connor, do you want me to do it for you? Yeah. Also, yeah. Okay. That was okay.
No, it's an isosceles triangle.
Not doing what we are.
You say yeah, I'm doing the exact same thing as you. Either isosceles triangle.
But we did something different than you. Where that is calculation something 307. Well, you thought this was everything.
Probably start by cutting it into right triangles and finding the hypotenuse. So, wonderful question from Jake. And good vocab word. Jake identified if this is the same as that, this is an isosceles triangle. And he's trying to cheat the system and just ask how we find the perimeter. There's no quick, easy way. Well, there probably is a quicker, easier way, but I don't know. Like, it normally involves a complicated formula. So the better option is let's just draw this line that you can't barely see. Make it a right triangle. I'm going to draw it in another color. Because we know, how long is this? 30. How long is this? Yeah, careful. Careful. Because they're not all identical. So keep going. Wrong answers are good. They lead us to the right answers.
I'm using a calculator.
And then we gotta do these two. But these are the same. I figured out that these are the same. Yeah, all these. We just gotta do one of them. Okay, so.
Wait, Mr. Hudson. If you find out one of these long ones, they should all be the same height.
Right.
Yes, you do.
Those triangles aren't the same as each other, though.
No.
Like that middle triangle looks like it's different than the other two triangles.
Yeah, but that doesn't mean the size of it. These sides should all be the same because they're going to be.
So you're saying that even though this isosceles triangle is more compressed than these isosceles triangles, that these hypotenuses will still be the same? Interesting.
Well, I know because this is 30.
Is this the same slope as like this? Like the same exchange of... Like I know that middle triangle I can cut nice.
I know these are the same.
Well, no, middle triangle can cut nice. It wouldn't be a nice number. The hypotenuse wouldn't be a nice number.
All right, I'm going to point out one of the trapdoors. I hear people saying like, oh, I did something wrong. And yeah, there is like an intense trapdoor here. How long is this to this? 7. Thank you. Brenda's going to be our label coach. How long is here to here? So if you said that this over here is 7, then if I draw this across, where's it hit over here? At 7. If I draw that horizontal line across the patio, oh, crumpled paper in frustration. This is 7, leaving how much here? 3.5. So the middle triangle, these two hypotenuses are probably the same as each other. But I don't think that this hypotenuse is the same as this one. Let's talk with each other. I got to do it on my own. Quit asking me. You got classmates to ask.
All our brain hurt against it.
We still have time.
Yes.
Could you also use this right here, this leftover part?
Absolutely.
And then, because we did
I think
that.
that's almost a better idea.
Okay, yeah.
I'm actually going to draw that on my
Okay,
paper.
that's what we did.
Hey, Amelia told me a better idea. It's less complicated because I don't have to draw so many things on top of each other. She said, hey, what if we just like use this triangle up here to figure out that first hypotenuse, and then I don't have to draw so much like nonsense in here? Yeah, absolutely. So I'm going to use these pink dimensions to figure out this first hypotenuse, and I think that's the same as on the other side of the patio. So keep rolling. That's a good idea. Keep rolling. We don't want to give everything away yet.
What do we do with them?
If you're done, then you got to do the flat families, the guy wires. Now, I do have to say something else since we've been chatting about Chelsea today. For as many jokes as I make, and trust me, she never watches my YouTube, so I don't care. But for as many jokes as I make, my wife is like seriously awesome. Any of these projects I do, she's always helping. So it's not one of those situations where the wife says like, do this thing, and then they disappear. She's like, can we do this thing, and how can I help? Right? So for as much as I like to joke about these things, my wife is pretty awesome. I told her that you made me a hat, Jordan, and she was like, do I get a Mrs. DJ Hudcap hat? And I was like, you don't ever DJ. I was like, why do you get a hat?
It could be Mrs.
Mrs.
Hudcap.
Hudcap? That's really funny. I don't know if she would want that name.
Wait, can we leave them in radical form?
I mean, since I'm going to have to buy this amount of lighting at Target, I don't think they're going to sell it in radical form. So decimals are just probably better here.
Yeah, so we can use 2 decimals instead of like.
Yeah, like to the hundredths place. Yeah, because I'm not going to be more accurate than I'm going to buy extra, right? Whatever I find, I'm going to go over.
This is a little extra, but I think this is around.
I don't know. I haven't done that problem yet, so I don't know.
I did it.
I'm on this problem still. You know how much teachers make, right? Not much. I did not go into this field to make a lot of money. If I wanted to do that, I would have been an accountant.
No, I know, but I'm saying if you were actually in this situation, you wanted to know how much light.
But Nolan, I was actually in this situation. I did actually go to Target and buy these lights, but I didn't want to buy enough extra that I had to go return them. So I did do the math. I'm not joking. This is something I did in my notebook at home. I've got like a project notebook. This is in my project notebook. Now, the next year we moved these poles a little bit, but still the amount of lights we had worked. What up, Jake? Yeah, they're right here. You guys, if you're going to use them multiple times, you guys can hang on to those like in Kabila's room or somewhere. They're measuring grass? Oh, they might be looking for a spot for 9 square or like different things like that. Yeah, 8th grade went to PTSA last night and proposed a bunch of give us money to buy new stuff that will benefit you guys more than it's going to benefit them. So, like, one of the things they're trying to do is Kelly Shaw is trying to get PTSA to buy 2 new 9-square sets that should be able to be set up in 5 minutes or less.
What are 9 squares?
If you haven't played it, the reason you haven't played it is it's a pain in the butt to set up, because the set that we have was, like, made out of PVC from Home Depot, not a set purchased from, like, the company. So, if PTSA buys it, we'll have 2 new sets of 9-square that, like, clip together, as opposed to, like, it's the big PVC thing where you're, pushing the ball up. And
I know why he's asking so much. He's pretty good.
well, yeah, but he's leaving. So the thing I'm trying to get you guys to realize is this is their impact project. So they're trying to leave an impact on the school.
So you're trying to leave the impact on the school's
I'm
budget.
working on the family's house.
Yeah, it is.
So I figured out that
Okay.
she'll need for that.
So the green one on the front will be the same one as the green one on the back.
Yeah, so
Okay.
that's why times 2.
Okay.
Or like that.
Okay.
Because do I need to
Hey,
explain
we're
the
not, the conversation's not 9-square. The conversation is like Pythagorean Theorem and hypotenuses. So let's refocus.
Do you want me to explain how I did that, or can I just answer the
Well,
question?
I mean, you can just ask your question because I haven't done this yet to really be able to tell you yes or no. You know what I mean?
I don't
I haven't
know.
done this in 2 years.
Okay, I don't know how to calculate this.
Well, let's go look at the box.
Okay,
This is why I made a model.
thank you.
Here, we'll get all professorial and use like a pointer and things.
Okay.
So you said you calculated these
Yes,
and you
because
calculated these.
what I did is just calculated
Yeah.
this length
So-
squared, this length squared.
So wait, since you're using this, I think to calculate this, we're gonna need to use this,
But I don't know that. And I don't
so we can figure it out. Do you know how long this is?
half of it is, that is the 32 line, so
Do you know how long this is? You don't need to tell me just yes or no. Like,
do I know how long that is?
yeah.
Yes.
What sort of shape does this, and this make?
A triangle.
Right? This is a hypotenuse. But then, as we flip up 3-dimensionally, you're ready to get your mind blown?
I mean, no.
No.
Like,
No.
Triangle on top of it.
what I was drawing
Where'd
on the
it
paper.
go?
It's the same angle here. So it's the same thing. So this is
All right, guys. Grab a seat so everyone can see the board.
Wait, I need to
As
on the ground.
as you get. Hey, grab a seat real quick. As you get to the flat family problem, what you're encountering. Yo. I don't care if you're not listening, but I do care if you're talking at the same time as me because I'm trying to blow your mind with knowledge. What you're going to encounter on the flat families problem is the guy wire coming from the corner of the roof makes a shadow onto the roof, but then it extends up to the antenna. We're going to have to calculate something before we can calculate the next something. So that's why I made this model for you. So you can come up, look at it, and reason your way through. And also, this didn't exist last year. CPM made this probably because they realized this is really hard to visualize. So I'm trying to find a 3-dimensional hypotenuse, which is essentially what we're doing. A 3-dimensional hypotenuse. I have to first find like the shadow of it, and then work from there.
You can measure the shadow.
We can calculate the shadow.
Measure it. We need to measure it.
I don't think you can because this isn't the actual roof.
Yeah, I know, but you find the height. You find that.
Hypotenuse of another triangle.
So you can calculate it, yes.
Also find it.
Most hypotenuses can't be found; they can just be calculated. Well, I don't know that. I shouldn't really say that. All right, you have all the knowledge you need for both of these problems. We are out of time, though.
No!
Yeah, we are.
I'm sorry, I don't make time. Talk to Dr. Strange. I don't have that ability.
Oh my gosh, I was actually having fun doing math.
I love Dr. Strange.
Well, what the
Oh, you were talking about math, not Dr.
Oh,
Strange.
I watched Dr. Strange.
Benedict Cumberbatch is my bro.
He's-
All right, let's get out of here, guys. We'll pick this up tomorrow. It's too fun. I don't want to rush through it.
You know Tom Holland learns like how to speak not British, like
No, wait, help me. Tom Holland plays
Spider-Man.
Okay, just check. Well, a lot of people have played Spider-Man, so let's back up.
So anyway, so he learned how to speak like American, like with American accent
Okay, yeah.
in like 2 weeks.
That's because he's an actor. He's trained. Like they
I know.
do voice training. Like
I know.
that is impressive.
It is. It's
But like, don't expect that you could do something like that unless you've gone through training. Because a lot of how we have an accent is our literal soft palate, the top of our mouth.